G'day. In this video, I'll have a look at the final setup of the netProbe network monitor running on an ESP32. First, I'll look at how I updated the Angular client application to look a lot better and be more usable than the MVP version that I showed in the last video. I look at a couple of fixes I made to improve the reliability of the micropython code, and then I'll discuss some of the problems I had with the ESP32 version of this application and updates on planning for a future netProbe. Okay, first let's have a look at the changes to the netProbeUI. This is the home page. You see it's got a border around it now. I also put in an ability to click on the heading to refresh it, or when you're in another page to return to the home page. If you click on one of the measurements, it takes you to the history page for that measurement, and then you can click between number of hours or days of measurements that you want to see in the history. And again, you can click on the heading to get back to the home page. And finally, if you click on one of the host names, that takes you into the update page. I made some changes here. It allows you to update and delete the host. So some changes in here is I've now framed the various tests to make it easy to see what controls go together. And I'm also using material controls for like the radio buttons and the drop downs and things. So let's have a look at some of the changes and where they're made. So I'm in my Angular application. First thing I'll look at is just the app component. So this wraps every other component. So just on the frame part of the pages, I've added padding and a max width of 800 just to frame all the pages, keep them to the same width. One of the other things I did up in, let's for example look at the host page in the HTML. So starting out with the HTML, I'm now using a matte card to wrap all the pages, so it gives it kind of a nice look that stands out from the rest of the page. And then I'm using the click action on the matte card title, and in the code behind this for the icon click, it's just returning you to the home page. And I've also got this on the home page, so if you click it in that, it just does a refresh on the home page. The host page again and the CSS for that. So I'm using a media version of CSS. So if it says that the device that's viewing the page has a width of less than 400 pixels, then it sets up the grid to only show one column of items. Otherwise, if it's more than 400 pixels, it then uses this grid information to say show 2 columns of information. So on smaller devices like a iPhone SE, you'll see this collapse to just 1 column of information, which makes it fit better on the screen. And the other thing I did was wrap the various sections here, like the ping section, in it's got an outline around it now. So again, in our grid wrapper, we can see it's got a border around it as a outset for each of these. And as well in here, you see I'm using matte labels, material checkboxes, and material selects to get the material look and feel to them. And finally down here you see the button, and there's some logic behind these buttons where the host page is using for add, delete, and update. So it only shows the appropriate button depending on whether you're doing an update, delete, or add. And there's some code behind this, for example, for the do action. If the action's a delete, then it'll confirm with this this confirm command here to make sure that you want to delete before it actually deletes the particular host. Otherwise it just does an update. So one interesting problem I ran into, I haven't had it before, was when I built the netProbeUI, it would send requests for page changes up to the server, and then the server would interpret it and actually try and send the page back. But because the routing structure inside the single page application, which is Angular, is not the same as what files are up on the server. Say basically it couldn't find the page. And I found out one way to get around that was to use a localization strategy. So I used this host localization strategy, and you see what it does is it puts a hash mark after the host name in the URL, and basically what that does is it then ignores anything after that hash mark. So it used to be used for doing things like positioning you on a certain part of an HTML page, but the nice thing is it ends up not sending anything after the hash up to the server. So that stopped the server even trying to respond. I think it got the route got intercepted on the single page application, was interpreted correctly. But to do that up in the app.module.ts in the providers, I had to add this location strategy, use the HashLocation strategy information to it, and then that solved things after I did a build. So the next thing I wanted to improve on was being able to set the location of the netProbe services at runtime. So otherwise I'd have to recompile the netProbeUI every time, because before I was keeping the netProbe host information in the environment settings, so they get built into the application at compile time, which means I couldn't change them afterwards. So what I did, and I got a link down below in the description of where I got most of the information on how to do this, was pick up the information I wanted from a file I put into the assets called config.json. So at the moment the only runtime configuration is the netProbe host, but this allows me, if I move it to a different location or have multiple ones, just to be able to tell the Angular program where to go for the services here at runtime, rather than having to recompile the program for each different location of the host. So the way that's done is down in the app module. You add in this section here, and again I've got information in the description on how to do that. So you set up an app initializer that's going to use the config service, which I created to pull the information from this assets config.json file. And that service I set up down in services. See the config service here, and basically it's going out and looking to pull in the assets config.json file, which is in JSON, and then setting this interface, this app config model, to whatever's in the config.json. So that's how the settings get into the program. And once they're there, we can have a look down, and let's have a look in Logger, which is one place I use it. So before I was getting the information about the netProbe host from the environment, but now I've brought in the service config service, which we just looked at, and I'm calling get config from the config service. So that's getting that what's in the assets config.json file and pulling the netProbe host and appending it to the rest of the URL, which is the request back to the backend service. Okay, moving over to the Python code running on the ESP32. I had to make some changes in here. So one big problem I ran into was with the scheduler. So remember, that's running in the background as a synchronous process, and if I got an error down in anywhere in the code in here, then the scheduler would stop running. But because the microDot was running as a separate process or separate thread, it carry on running. So it's kind of weird. I'd see all the tests to host stop, but the website would be still responsive, but just wouldn't show any updates. So to get around that, I just put a big try block around the scheduler code, and then down here, and as the exception for that, I print the exception just in case I want to see it in real time if I'm watching the code. I also write out the exception to the app logger, so that puts an entry in the logger file, so I can have a look at that later. And then the whole thing just restarts, and I don't get these errors too often. I mean, it seems to be mainly connected with memory errors, but at least when I get this error now, it basically says, hey, I can't fix this, and restarts the whole application. Startup isn't. So through this whole thing, memory was a challenge. I think running microDot, which is fairly memory intensive, along with a lot of these network tests, which use a lot of things like the HTTP client and pings and bings and a lot of network stuff, libraries that I have to bring in. I think it's just consuming a lot of heap. So to help as much as possible, you see here in the list of libraries, I've basically turned everything that's a separate library into a MPYed or precompiled micropython file. So that helps with, at least when using the heap to bring these in and imports, it doesn't have to actually compile, so heap gets less fragmented that way. I also had to take a lot of comments out of the code. Even with all that, I still find things start getting unreliable, and my memory starts getting a bit worrying whether it can allocate enough memory for some of the operations if I have more than about 10 hosts going, because just the size of the hosts in memory seems to cause problems with available memory and needing to be able to allocate enough room for that large object. So let's have a look at what I'm thinking to do next to sort of help with that. So I had some thoughts on this. So I think I'll probably change over to using like a Linux based operating system. The microDot and all the network stuff work well, but it's just too tight to get it all running on a ESP32, especially in MicroPython. Maybe in C it'd be easier to have enough room and control the memory. So I'm planning on changing to one of these. This is a Orange Pi Zero. It's like a Raspberry Pi Zero, but it has a built-in network adapter, and these are pretty cheap. This was about $32 on Amazon. If I went to AliExpress, it's probably about $20 plus shipping. So on this I can run Ubuntu, and I can probably do more what I was doing with the Solar Shared project of running Linux on there with Python and Flask. So the good thing is microDot API is very much like Flask, so I don't think there'll be many changes there. And also previously I'd made a Python version of the Bing and Ping and web check tests that just ran on straight Python 3. So I think I can use those or just modify the versions that I've got for the ESP32 again. So I think putting all that together should be good. And then I always have trouble with deploying to a Raspberry Pi. So what I'm thinking this time is I'll try and wrap all that up into a Docker container. So if I want to deploy it to a Raspberry Pi or one of these orange Pis, I can just have Docker running there and deploy the Docker container. It should make it a lot easier. And that might also give me an option to deploy it to something like my Synology NAS if I wanted to have it running there rather than on a small separate device. So that's the plan. I think it'll probably take 2 or 3 videos to get through that. So hold on, I'll try that. And again, I'll put all the code up in GitHub, especially if I get there, a Docker container image.